Introduction.
Anvesha, are you looking at the ship?
Yes, it is such a beautiful sight. See?
You are right. Do you realize that your line of sight forms an angle of 45 degrees with the ground?
You are right, Vedika.
If I told you that the distance between our building and the ship is 10 meters, can you tell me the height of this building?
Yeah, sure. I have learnt my trigonometry well. The answer to your question, that is, height of building is 10 meters.
Anvesha used trigonometry to answer Vedika's question. In this lesson, you will learn about the relationship between angles and sides of a triangle. Objectives. At the end of this lesson, you'll be able to define trigonometric ratios of angles, calculate trigonometric ratios of specific angles, compute trigonometric ratios of complementary angles. Origins of trigonometry. The word trigonometry derives from two Greek words, trigon, meaning triangle, and metria, meaning measurement. Thus, trigonometry represents a branch of mathematics that examines the relationship between the sides and angles of a triangle. The Egyptians and Babylonians were the first to use trigonometry for astronomical studies. The Greek astronomer and mathematician Hipparchus compiled the first trigonometric table. That is why he is considered the father of trigonometry. Trigonometric ratios. Let us begin our introduction to trigonometry with trigonometric ratios. We will express the angles as trigonometric ratios, compare trigonometric ratios of similar triangles, and solve examples. Angles as trigonometric ratios. Look at triangle XYZ, right-angled at Y. Angles X and Z are both acute. XY is the side opposite to angle Z. YZ is the side adjacent to angle Z. XZ is the hypotenuse. Let us now express different measures of angle Z as ratios of the sides of triangle XYZ. Sine of angle Z is equal to sine Z, which equals opposite side upon hypotenuse. Cosine of angle Z is equal to cos Z, which equals adjacent side upon hypotenuse. Tangent of angle Z is equal to tan Z, which is equal to opposite side upon adjacent side. Cosecant of angle Z is equal to cosec Z equals 1 upon sin Z equals hypotenuse upon opposite side. Secant of angle Z is equal to sec Z equals 1 upon cos Z equals to hypotenuse upon adjacent side. Cotangent of angle Z is equal to cot Z equals 1 upon tan Z equals adjacent side upon opposite side. Greek letter theta is used to represent an angle. Therefore, sin Z may be written as sin theta. Similarly, cos Z is equal to cos theta, tan Z is equal to tan theta, cosec Z is equal to cosec theta, sec Z is equal to sec theta, and cot Z is equal to cot theta. Trigonometric ratios of similar triangles. Consider the two triangles, triangle ABC and triangle DEF. Angle A is equal to angle D. Angle B is equal to angle E. Angle C is equal to angle F. Hence, triangle ABC is similar to triangle DEF by AAA criterion of similarity of triangles. Therefore, the corresponding sides of the two triangles are proportional. Thus, it is clear that trigonometric ratios do not change with changes in the sides of a triangle as long as the angles remain unchanged. Examples. Let us look at some examples to consolidate our understanding of trigonometric ratios. It is given that triangles ABC, right-angled at B, cos A is equal to 5 upon 13. Find the other trigonometric ratios. Cos A is equal to AB upon AC, which is 5 upon 13. It means that the sides AB and AC are in the ratio 5:13. Therefore, we can say that AB is equal to 5A and AC is equal to 13A, where A is a positive number. According to Pythagoras' theorem, AB square plus BC square is equal to AC square. By substituting the values, we get 5A square plus BC square is equal to 13A square. Now, by calculating it, we get BC as square root 114A square, which is 12A. Let us now find the values of the other trigonometric ratios. Sin A is equal to BC upon AC equals 12A upon 13A equal to 12 upon 13. Tan A is equal to BC upon AB equals 12A upon 5A, which is equal to 12 upon 5. Cosec A is equal to 1 upon sin A, which is equal to 13 upon. Sec A is equal to 1 upon cos A, which is equal to 13 upon 5. Cot A is equal to 1 upon tan A, which is equal to 5 upon 12. Consider right-angled triangle PQR. Find the values of sin square R, cos square R, tan square R, sec square R minus 1. According to Pythagoras' theorem, PQ square plus QR square is equal to PR square. By substituting the values, we get 3 square plus 4 square equals PR square. Now, by calculating it, we get PR is equal to square root 25, which is 5 centimeter. Now, sin R is equal to PQ upon PR, which equals 3 upon 5. Sin square R is equal to 3 upon 5 whole square, which is 9 upon 25. Cos R is equal to QR upon PR, which equals 4 upon 5. Cos square R is equal to 4 upon 5 whole square, which is 16 upon 25. Tan R is equal to PQ upon QR, which equals 3 upon 4. Tan square R is equal to 3 upon 4 whole square, which is 9 upon 16. Sec R is equal to 1 upon cos R, which is 5 upon 4. Sec square R minus 1 is equal to 5 upon 4 whole square minus 1, which is equal to 25 upon 16 minus 1, which gives 9 upon 16, which is tan square R. Trigonometric ratios of specific angles. Having understood trigonometric ratios, let us now compute trigonometric ratios of 30 degree, trigonometric ratios of 60 degree, trigonometric ratio of 45 degree, trigonometric ratio of 0 degree, trigonometric ratio of 90 degree. Trigonometric ratio of 30 degree. Consider the equilateral triangle XYZ. XY is equal to YZ, which is equal to XZ, which equals S. Angle X is equal to angle Y, which equals angle Z. Let us now draw a perpendicular from vertex X to intersect side YZ at T. In triangles XYT and XZT, XT is equal to XT, common side. XY is equal to XZ, given. Angle XTY is equal to angle XTZ, right angles. Therefore, triangles XYZ and XTZ are congruent by RHS congruence. Therefore, angle YXT is equal to angle ZXT, which is 30 degree. YT is equal to ZT, which is 1 upon 2s. According to Pythagoras' theorem, in triangle XYT, xt square plus yt square is equal to xy square. By substituting the values, we get xt square plus 1 upon 2 s whole square equals s square. Now, by calculating it, we get xt square is equal to square root 3 upon 4 s square is equal to square root 3 upon 2s. Sin 30 degree is equal to yt upon xy equals 1 upon 2s upon s is equal to 1 upon 2. Cos 30 degree is equal to xt upon xy, which equals square root 3 upon 2s equals square root 3 upon 2. Tan 30 degree is equal to yt upon xt equals 1 upon 2s upon square root 3 upon 2s equals 1 upon square root 3. Trigonometric ratio of 60 degree. Consider the same equilateral triangle XYZ. Recall that xy is equal to yz, which equals xz, which is equal to s. Angle x is equal to angle y equals angle z. YZ is a perpendicular from vertex x, which intersects side yz at T. Triangles XYZ and XTZ are congruent. Therefore, yt is equal to zt equals 1 upon 2s. According to Pythagoras' theorem, xt square plus yt square is equal to xy square. By substituting the values, we get xt square plus 1 upon 2s whole square is equal to s square. By calculating it, we get xt is equal to square root 3 upon 4s square, which is square root 3 upon 2s. Sin 60 degree is equal to xt upon xy, which equals square root 3 upon 2s upon s equals square root 3 upon 2. Cos 60 degree is equal to yt upon xy equals 1 upon 2s upon s equals 1 upon 2. Tan 60 degree is equal to xt upon yt equals square root 3 upon 2s upon 1 upon 2s equals square root 3. Trigonometric ratio of 45 degree. Consider the right-angled isosceles triangle XYZ. xy is equal to yz, which equals s. Angle y is equal to 90 degree. Angle x is equal to angle z, which is 45 degree. According to Pythagoras' theorem, xy square plus yz square is equal to xz square. By substituting the values, we get s square plus s square is equal to xz square. xz square is equal to 2s square, which is xz is equal to square root 2s. Sin z is equal to sin 45 degree, which equals xy upon xz, which equals s upon square root 2s, which is equal to 1 upon square root 2. Cos z is equal to cos 45 degree, which equals yz upon xz is equal to s upon square root 2s is equal to 1 upon square root 2. Tan z is equal to tan 45 degree, which equals xy upon yz, which equals s upon s, which is equal to 1. Recall the discussion of Vedika and Anvesha at the beginning of the lesson. Height of building upon distance between building and ship is equal to tan 45 degree. By substituting the values, we get height of building upon 10 meters, which equals 1. Therefore, height of building is equal to 10 meters. Trigonometric ratio of 0 degree. Consider the right-angled triangle XYZ. Reduce the measure of angle Z slowly. You can see that XZ rotates left and becomes flatter. When the measure of angle Z is reduced to 0 degree, XZ merges with YZ and the length of xy is 0. Let us understand what happens to the values of trigonometric ratios. Sin z is equal to sin 0 degree, which is equal to xy upon xz, which equals 0 upon xz, which is equal to 0. Cos z is equal to cos 0 degree, which equals yz upon xz, which equals 1, as yz is equal to xz. Tan z is equal to tan 0 degree, which equals xy upon yz, equals 0 upon yz is equal to 0. Trigonometric ratio of 90 degree. Consider the right-angled triangle XYZ. Increase the measure of angle Z slowly. You can see that XZ rotates right and becomes steeper. When the measure of angle Z is increased to 90 degree, XZ merges with XY and the length of YZ is 0. Let us understand what happens to the values of trigonometric ratios. Let us understand what happens to the values of trigonometric ratios. Sin Z is equal to sin 90 degree, which equals xy upon xz, which equals 1, as yz is equal to xz. Cos Z is equal to cos 90 degree, which equals yz upon xz, is equal to 0 upon xz, which equals 0. Tan Z is equal to tan 90 degree, which is equal to xy upon yz, equals xy upon 0. Therefore, tan 90 degree is undefined. Let us summarize our exercise in a table. Trigonometric ratios of complementary angles. Two angles are said to be complementary if the sum of their measures equals 90 degree. Consider the triangle XYZ, right-angled at y. Angle x plus angle y plus angle z is equal to 180 degree. Angle y is equal to 90 degree. Angle x plus angle z is equal to 180 degree minus 90 degree equals 90 degree, which implies angle x as 90 degree minus angle z. Or simply, x is equal to 90 degree minus z. Let us first list the trigonometric ratios of angle z. Sin z is equal to xy upon xz. Cos z is equal to yz upon xz. Tan z is equal to xy upon yz. Cosec z is equal to 1 upon sin z equals xz upon xy. Sec z is equal to 1 upon cos z equals xz upon yz. Cot z is equal to 1 upon tan z equals yz upon xy. Let us now list the trigonometric ratios of angle x. Sin x is equal to sin 90 degree minus z equals yz upon xz equals cos z. Cos x is equal to cos 90 degree minus z equals xy upon xz is equal to sin z. Tan x is equal to tan 90 degree minus z equals yz upon xy equals cot z. Cosec x is equal to cosec 90 degree minus z equals xz upon yz equals sec z. Sec x is equal to sec 90 degree minus z equals xz upon xy equals cosec z. Cot x is equal to cot 90 degree minus z equals xy upon yz equals tan z. Let us first compile our observation and then use it to solve questions. Sin 90 degree minus z is equal to cos z. Cos 90 degree minus z is equal to sin z. Tan 90 degree minus z is equal to cot z. Cosec 90 degree minus z is equal to sec z. Sec 90 degree minus z is equal to cosec z. Cot 90 degree minus z is equal to tan z. Solve sec 21 degree, cosec 79 degree. Sec 21 degree is equal to cosec 90 degree minus 21 degree equals cosec 79 degree. Therefore, sec 21 degree cosec 79 degree is equal to cosec 79 degree cosec 79 degree, which equals cosec square 79 degree. Let us solve the same question in a different way. Cosec 79 degree is equal to sec 90 degree minus 79 degree equals sec 21 degree. Therefore, sec 21 degree cosec 79 degree is equal to sec 21 degree sec 21 degree, which equals sec square 21 degree. Let us attempt one more question. If tan A square is equal to cot 90 degree minus 25 degree, compute the measure of angle A. Tan A square is equal to cot 90 degree minus A square. Therefore, tan A square is equal to cot 90 degree minus 25 degree may be written as cot 90 degree minus A square equals cot 90 degree minus 25 degree. It implies that 90 degree minus A square is equal to 90 degree minus 25 degree. In other words, A square is equal to 25 degree. A is equal to 5 degree. Did you know? Trigonometry is used to calculate the distance between celestial bodies and the height of tides in oceans. Is a popular mnemonic used to remember trigonometric ratios. It means sine opposite upon hypotenuse, cos adjacent upon hypotenuse, and tan opposite upon adjacent. The word cosine sounds similar to its Sanskrit counterpart, kotijya, used by Aryabhatta. The word sine derives from the Latin translation sinus of jiva or jya, used by Aryabhatta to denote half-chord. Summary. Let us summarize what we have learned. Trigonometric ratios of acute angles in a right-angled triangle. Trigonometric ratios of specific angles such as 0 degree, 30 degree, 45 degree, 60 degree, and 90 degree. Trigonometric ratios of complementary angles.